All right, this one's a bit nasty because it's got a leading coefficient that is a fraction. So it's still, we just deal with it. So we got to factor out the negative a half. So I'm going to go y equals negative 1/2, and I'm dividing both the first two terms by negative 1/2. So negative a half divided by negative half is 1, so it always just is x squared. But then when I divide negative 3 by negative a half, it's inverted and multiplied, so it's negative 3 times negative 2, which is positive 6x. Leave lots of space, and then minus 7/2 outside the brackets. Now I'm going to complete the square, and again, I take half of the middle term. So 6 divided by 2 is 3, squared is 9. So I'm going to add 9 and subtract 9 inside the brackets. These three are a perfect square trinomial because 3 times 3 is 9 and 3 plus 3 is 6, right? So now I'm going to multiply negative a half times negative 9 is positive 9/2. So I get y equals negative 1/2 x squared plus 6x plus 9 plus negative times a negative is positive. Remember, it's a 9/1, so that's why it's just 1 times 9 is 9 over 2 times 1 is 2 minus 7/2. This is nice that these two have a common denominator, so they're easy to subtract. You just subtract the numerators. So I end up with factoring the x squared plus 6x plus 9. I get y equals negative 1/2. Remember, add to 6, multiply to 9. 3 times 3 is 9. 3 plus 3 is 6. So it's just x plus 3 squared. 9 minus 7 is 2/2 is 1. So this is just going to be plus 1. This one's actually the nicest vertex we've had. So the vertex is at negative 3, 1. And we're ready to graph this. Vertex at negative 3, 1. And then the a value is negative a half. So I'm going to go 1 to the left, 1 to the right from the vertex, and a half down. Normally 2/4 up, but now it's half of 4 and it's down. So it's going to be 2/2 down to the left, 2/2 down to the right. And I think that's enough points. And we can sketch this in. And again, because this was a negative leading coefficient, this has a maximum value of 1 when x equals negative 3, which both of those values, the 1 and the negative 3, are really just from the vertex, right? The vertex is negative 3, 1. And we're done.